Hey, student, how are you? Welcome to our session on functions. We're going to do 6 problems. All right, let's take a look. Number 1, we've got function notation, and this is pronounced f of x. F of x is really the y value, the output. A, find the output when x is 7. And we'll find the y value. So f of 7, we'll substitute 7 in for x. And we'll find f of 7. F of 7, when we put 7 into the function, we get 11 out. So you could write this as x comma y. Part B, find the input x when given the output y. So here we're given f of x is equal to 5. So we'll replace f of x with 5. Replace f of x, the y value, with 5. And then we'll solve for x, the input value. We'll add 3, bring it over to the other side of the equal sign. And we get 8 is equal to 2 times x, divide by 2. And we get x is 4. So 4 comma 5, or we could write it as f of 4 is equal to 5. Moving on. Number 2, continuing to work with function notation. Letter A, find f of 12. This means substitute 12 into the function and find the output or the y value. So we've got f of 12, and we'll substitute 12 in for x. And 1/4 of 12 is 3. And we see that when we put 12 into the function, we get -2 out. So I could write it as x comma y, a point. Part B, find x given f of x is equal to -3. So this means that the y value is equal to -3, the output. So we're going to replace f of x. We're going to replace f of x with -3 and then solve this equation for x. And we'll add 5, bring that over to the other side. And dividing by 1/4 is the same as multiplying by 4. We get 8 for x. X comma -3. This is our input value and our output value. F of 8 is equal to -3. Moving on. Number 3, we'll use the graph and work with function notation. Letter A, f of -1. This means when x is -1, what is the y value? Now we'll go over here to our graph and we'll find x is -1. And we'll go up to the point and we see that our y value, our output, is 2. -1, comma 2. So f of -1 is 2. And then going the other way, find the x value given f of x is 4. So this question is giving us the y value of 4. So we're going to find the y value of 4. Here's y is 4. And we see the x value is 0. So 0 comma 4. X is equal to 0. Moving on. Number 4. So we've been talking a lot about functions. What is exactly a function? Well, a function is a relation where each input is assigned to exactly one output. Each x value is mapped or assigned to one y value. And we'll take a look at these 3 mapping diagrams and see which one represents a function based on the definition. All right, starting over here on the left, we see that the left-hand circle is the domain and the right-hand circle is the range. And here, the input 2 is mapped to 3. 2 is not mapped to anything else. 3 is mapped to -4. 3 is not mapped to anything else. 4 is mapped to 0 and nothing else. 5 is mapped to -1 and nothing else. So yes, we have a function. Each input or domain value is mapped to only one y value, one value in the range. The middle one, we have the x values and the y values. 2, the x value is mapped to 8, the y value, and nothing else. 3 is mapped to 10 and nothing else. 4 is mapped to 12, and the x value 4 is also mapped to 14. So this is not a function since the x value 4 is mapped to 2 y values, not a function. X equals 4 is mapped to 2 y values. And the last one, inputs and outputs. We see that 2, the input is mapped to 10 and nothing else. 3 is mapped to 10 and nothing else. 4 is mapped to 20 and nothing else. 5 is mapped to 20 and nothing else. This is a function. Each input value is mapped to only one output. Moving on. Another way to determine whether a relation is a function is to use the vertical line test. This is especially useful when you have a graph. And the vertical line test says that if you can draw a vertical line anywhere through the graph and hit only one single point, then it is a function. And I could draw a vertical line here, and I hit the graph just one time right here. And we'll do one more for good measure. I hope you can tell that this is a function. This passes the vertical line test. Yes, function. Passes vertical line test. Everywhere we draw a vertical line, we hit only one point. All right, this ellipse, if we draw a vertical line, I hit 2 points. The x value of -1, is mapped or assigned to 2 y values, both -1 and +1. So this is not a function. Doesn't pass the vertical line test. And the last one, if we draw a vertical line anywhere through this graph, we will hit exactly 1 point. This is a cubic function, y equals x cubed, polynomial function. Polynomials are functions. Yes, this is a function. And moving on to our last problem. Number 6. We'll take a look at some table of values. I gave you a horizontal table, a vertical table, and then a graph. We're going to determine the domain and range, and then is it a function? And we'll start over here on the left with this first one. We see that 1 is mapped to -5. 1 is not mapped to anything else. 2 is mapped to 3, 3 is mapped to 7, and 4 is mapped to -5. This is a function. Each x value is assigned to only one y value. Yes, is assigned. And the middle one, do you see it? This is not a function. For the x value is mapped or assigned to two y values, -7 and -2. So this is not a function. And the last one, using our vertical line test, we see that this is not a function. The x value of 1 is mapped to two different y values. Oh, we've got to do our domain and range. Well, that's pretty straightforward. The domain, the x values, I'll use a squiggle bracket there. We've got 1, 2, 3, and 4 are the values in the domain, the x values. And we'll do the range down here. We've got the -5, 3, and 7. You don't have to list a domain value twice, even though it appears twice. Domain, x values, range, y values. And then this one, domain, we'll do this one. We've got the x values, -3, -1, 0, 1, and 2. And then our range, we have 0, -3, comma 0, -1, -3, 2, 3, and 4. And that concludes Functions Introduction. Thanks so much for joining this session, and I'll see you next time.